Hello students, welcome to AMIT'S Tuition Center. Today we will discuss the numericals of plus 2 class of chemistry subject. The chapter number is 2, that is solutions. First of all, we will discuss the numericals based on the molality and mole fractions. So first of all, we will discuss the formulas of molality and mole fraction, and then we will solve the numericals here. The first formula is molality. Molality is the moles of solute. First of all, we have to determine which one is solvent and which one is the solute, and we have to calculate the moles of the solute divided by the total volume of the solution multiplied by 1000. And formula of molality is the moles of solute, but here it is not the volume of the solution, but here it is the mass. There is a difference between the moles and the mass. Moles can be calculated from the molar mass and the actual mass given in the question. So here first of all we have to calculate the moles of solute and divide by mass of the solvent. First of all we have to determine which one is the solute and which one is the solvent, and then we have to put the value of the mass of solvent in the lower case. In the upper case we have to first of all calculate the moles of the solute multiplied by again 1000. And mole fraction is the number of moles of the component. Means we have to calculate the mole fraction of which of the solute or solvent, which element or compound. We have to calculate the mole fraction of which component. First of all we have to determine it, that is given in the question. So we have to put here the number of moles of the component. Moles of the component should be put which is to be determined. If we have to calculate the moles of the glucose, then put the values of the moles of glucose here, divide by moles of this glucose and water or any other component given in the equation. Okay, so here first we have formulas are written and we have to solve the first numerical. In the first numerical it is given that 2.82 grams of glucose, and the molar mass of glucose is given to be 180, are dissolved in the 30 grams of water. So solvent solute which is added in the solvent, and solvent in which solute is added. So here solvent is the water and solute is the glucose, and molar mass of glucose is given to be 2.82 grams, and we have to calculate first of all molality. First of all we have to calculate the molality, and formula of molality is given to be first of all molar mass of glucose is given to be 180, and mass of glucose is given to be 2.82 grams, and we have to calculate the molality, and formula of molality is given to be moles of solute, and here solute is glucose. Solute is here glucose C6H12O6 divided by mass of solvent. Mass of solvent. Solvent here is water. Solvent here is water multiplied by 1000. First of all we have to calculate the moles of solute. Moles of solute that is C6H12O6. The formula of moles of solute is molar mass divided by actual mass given. Actual mass upon molar mass. Moles of solute can be calculated, that is actual mass upon molar mass. Actual mass is given to be 2.82 grams divided by molar mass is given to be 180, and you have to calculate of a solvent. And what is the here? Solvent is the water, and mass of solvent is given to be 30 grams. Mass of solvent here given is to be 30 grams. So we will put all the values in this formula, that is molarity is given to be moles of solute is 282 upon 1800 divided upon 30 grams multiplied by 1000. So here by doing all the calculations, the answer is given to be 0.522 molar. Now we have to calculate the mole fraction. P part is mole fraction of glucose as well as water. First of all, we will calculate the mole fraction of glucose. So formula of mole fraction is number of moles of that component. So here we have to calculate the mole fraction of the glucose. So first of all, we calculate the number of moles of the glucose. So moles of glucose is actual mass here 2.82 grams divided by molar mass is given to be 180, and this point comes here to be 1800. So divide by number of moles of all the components. So we have to calculate the moles of water also. So in this question there are two components, glucose and water, and we have to calculate here all the components means we have to calculate the number of moles of both water as well as glucose. Moles of glucose is actual mass upon the, here actual mass is given to be 30 grams and molar mass of glucose is 18. So we will put the values of mole fraction of glucose. Mole fraction of glucose is divided by this mole fraction of glucose plus mole fraction of water. Okay, so mole fraction of water, if we have to calculate mole fraction of water, we have to put above the moles of the water here, 30 upon 18 divided by number of moles of all the components, that is 282 upon 1800 plus 30 upon 18. By solving all the calculations, we will mole fraction of glucose is 0.009 and mole fraction of water is 0.991. So our next question is a solution of glucose that molar mass is 180 grams per mole. A solution of glucose in water is labeled as 10% by mass, means the solution of glucose is 10 grams the total mass of the water. What would be the molarity and molarity, and density of solution is given to be 1.2 gram per liter. First of all, we will calculate the molarity. So the formula of molarity is again moles of solute. Here the solute is again glucose and solvent is the water, and we have to calculate the moles of the solute. Moles of solute means moles of glucose C6H12O6, which is equals to moles of solute, that is equal to the actual mass. Actual mass here it is given to be 10%. 10% means equal to 10 grams. So actual mass is given to be 10 grams and molar mass is given to be 180. And we have this is the moles of the glucose and the mass of solvent. Mass of solvent here is water. So mass of water is given to be, here mass of in water, a solution of glucose is labeled as molar mass of water So the here the given is the solution of glucose, means this is the whole solution. This is the whole solution, and here solute plus solvent. So solute is given to, this is solution that is 100%, in which solute is 10%. So the rest of will be 90%. So the 90% means 90 grams. So mass of water is 90 grams. We have to put the value in the molarity in the formula, and we will calculate molarity. Moles of solute is given to be 10 upon 180 upon 90 multiplied by 1000, which is can be 10 upon 180 into 1 upon 90 multiplied by 1000. So solving all these equations, we will calculate the value of the molarity, which is given to be 0.618 molar. Now we will calculate the molarity here is the moles of solute. Again solute is here glucose, C6H12O6 upon volume of solution. Here it is not mass of solvent, it is volume of solution multiplied by 1000. So moles of, first of all we have to calculate the moles of the glucose, which is glucose moles is moles of solute, that is actual mass upon actual mass. Here it is given to be 10 divided by molar mass is 180. It comes out to be 0.556. So now we have to calculate the volume of the solution. So it is here the formula, volume is equals to mass upon density, mass of solution upon density. So mass of solution, in the solution it includes both solute as well as the solvent. Solution is the combination of both solute and the solvent. So here 10% is the solute and 90% is the solvent. So total mass will be 100%. So mass will be 100, and density here is given to be 1.2 grams. And by solving these equations, we will calculate that volume is 83.3. Here is the mistake. Moles of solute is 0.0556. So we have calculated the moles of solute and volume of the solution. So we will put here in the formula molarity. Moles of solute is 0.0556 upon volume is given to be 83.3 multiplied by 1000. By doing all the calculations, we get that molarity is given out to be 0.667 molar. So now moving on to the next question. Next question is based on the Lord's law. That is the Lord's law says that PA is equals to PA naught multiplied by XA, and PB is equals to PB naught into XB. PA is the vapor pressure of the pure component. Here vapor pressure of the pure component A and vapor pressure of that component in the solution, and XA is the mole fraction of that component A. Okay, and here the PB is equals to PB naught is the mole fraction, vapor pressure of that the pure component, but is the vapor pressure of that pure component AB, and the PB is the vapor pressure of the PB component B in the solution, and XB is the mole fraction in the solution. So here I have written the numerical vapor pressure of the ethyl and copper. So ethyl and copper is any component which is known to be X, which is component A. Okay, vapor pressure. So vapor pressure of ethyl and copper at 298 Kelvin is 40 mm of mercury. Means vapor pressure of ethyl alcohol is given to be 40 mm. So PA is given to be 40 mm of mercury and its mole fraction, that is XA, is given to be 0.80. What is the vapor pressure in the solution? We have to calculate PA. So according to the Rod's law, PA is equals to PA naught multiplied by XA. So we have to calculate the vapor pressure in the solution. We have to calculate this PA. If PA naught is given to be 40 mm, if PA is given to be 40 mm of mercury multiplied by mole fraction. Mole fraction, here the mole fraction is given to be 0.80, and by doing all the calculations, 40, 0.80, 32. So here the vapor pressure is given to be 32 mm of mercury. Now solving another question. In the next question, it is given that an aqueous solution of glucose is made by dissolving 10 grams of glucose in 90 grams of water. Means 90 grams of water is added to the 10 grams of 10 grams of glucose is added to the 90 grams of the water at 303 Kelvin. If a vapor pressure of pure water is 32.8 mm of mercury, what would be the vapor pressure of the solution? We have to calculate the vapor pressure of the solution. Let water be component A. According to the Rod's law, PA is given to be PA naught into XA. So PA naught is the vapor pressure of the pure component A. Pure component A is the water, and the vapor pressure of pure component water is given to be 32.8 mm of mercury. So PA naught here it is given to be 32.8 mm of mercury, and we have to calculate the mole fraction of the water. So to calculate the mole fraction of water, so we have to calculate the moles of water upon moles of water plus moles of glucose. Moles of glucose. So the moles of water. So in this calculate the moles of water. It is actual mass upon molar mass. Actual mass upon molar mass. Molar mass is given to be 18, and in this the question it is given to be 10 grams, and moles of glucose. Moles of water is given to be 90 grams, and moles of glucose is the moles of glucose C6H12O6. Moles of glucose, again actual mass upon molar mass. So the molar mass is 180, and actual mass here is given to be 10 grams. So by calculating this question, so we have to calculate the vapor pressure of the solution. Vapor pressure of the solution comes out to be, moles of water comes out to be 5.0, and mole fraction of glucose comes out to be 0.0556, and we have to calculate the mole fraction of the solution, that is both. So mole fraction of solution, so which is 5.0 upon 5.0 plus 0.056 by doing all the calculations, it comes out to be 0.989 PA naught multiplied by XA. XA, we have calculated the value of XA, which is 0.989, and we have to calculate what will be the vapor pressure of the solution. We have to calculate the value of PA, and PA naught is given to be 32.8 mm of mercury. By doing all the calculations, it comes out to be 32.44 mm of mercury. So we will continue these numericals in the next video. Till then, please like, share and subscribe the channel. If you have any query, please visit AMIT'S Tuition Center. The address